In this experiment, you'll be introduced to the Arduino board and to coding in C language. First, let's create a new breadboard circuit. Delete the breadboard. And add an Arduino Uno board to the circuit. Hide the components and zoom to fit. So this is what a real Arduino board looks like. The key part of the Arduino board is what's called a microcontroller. It's like the processor chip inside your computer, only it's a lot less expensive and not quite as powerful. A lot less powerful, actually. These black things here are called headers, and they have holes that you can put wires in, and the holes are called pins. These pins here with the G and D next to them, the three of them, are ground pins, and they work just like the negative terminal of a battery. These two pins here, 5 volt and 3.3 volt, they work like the positive terminal of a 5 volt or 3.3 volt battery. And by combining these pins, we can power external circuits. In fact, we'll do that now with a LED and a resistor. Rotate the LED and rotate the resistor. And we're going to change the resistor's value to 330 ohms like this. And connect the resistor to the ground pin, this ground pin here. Doesn't matter which one we use actually. And we're going to connect the positive terminal of the LED to the 5 volt pin and start the simulation. So we can see that the LED does light up just like when we used a battery. And notice also that this little light here is blinking. This is an on-board LED. It works just like the other LED, but it's built into the circuit. And it's flashing. It's at 1 second intervals. It's on for 1 second, off for a second, and so on. Now let's stop the simulation, and we're going to replace our connection to the 5 volt pin with the connection to pin 13 here. So first I'm going to reposition this resistor. And then connect to pin 13. And start the simulation. Okay, notice that the LED is now blinking at 1 second intervals just like the on-board LED. And the reason that's happening is that there's actually a program inside the microcontroller. It comes pre-installed with the Arduino board, and that program is telling the board to put voltage on pin 13, 5 volts for 1 second, then 0 volts for 1 second, then 5 volts for 1 second, and so on forever. To see the program, click on the Code Editor button and drag it up to see all the code. And so you've probably heard of coding, and this is C language programming code right here. And this is what is telling the Arduino board to put the high voltage and low voltages on pin 13 at 1 second intervals. So here's where we tell it that we want to use pin 13. This line of code is telling the board that we want to use pin 13 for output. We can also use these pins for inputs, so that's why we have to tell it ahead of time what we're going to do. These 4 lines of code are inside of a loop function, what we call a function. And the loop function is run by the Arduino board over and over again. So whatever you put inside this loop function will be run over and over again forever until we tell it to stop. So the first line of code in the loop function tells the board to put a high voltage on pin 13. And on Arduino boards, a high voltage is 5 volts. So that lights up the LED. Next line of code tells the Arduino board to do nothing for 1,000 milliseconds. And 1,000 milliseconds is 1 second. Next, we tell the board to put a low voltage on pin 13. And a low voltage is about 0 volts on an Arduino board. And lastly, we tell it to do nothing once again for 1 second. And then it does it all over again. So 5 volts for 1 second, set 5 volts, wait a second, set pin 13 to 0 volts, wait a second, and do it all over again. Now we're going to change the 1,000 milliseconds to 500 milliseconds, which is a half second. And we're going to upload this code to the microcontroller and run it. Okay, notice now that the LED is blinking at a faster interval because we're telling it to turn on for a half second, then off for half second, on for half second, etc. Okay, now let's change the code to use pin 12 instead. And upload and run the code. Okay, notice now that the LED does not light up at all. In fact, neither LED lights up, and that's because we're no longer telling it to put voltages on pin 13. We're telling it to put the voltages on pin 12. Now let's stop the simulation and connect to pin 12 instead and see what happens. Okay, so once again, the external LED is blinking at half-second intervals, and the onboard LED is not doing anything because we're no longer telling it to put voltages on pin 13.